Hi there, my name is Ulysses Elias. I am taking the course of Machine Learning Foundations for Product Managers in Coursera. And this is a video to show one of the tasks. It is an exercise to apply the new knowledge about modeling process in order to develop a machine learning model. And some of the things that are going to be evaluated are the approach to creating the model, building the model, and evaluating the model, as well as interpreting the model. And this is going to be applied to a target variable, which is to predict the electrical energy output of a combined cycle power plant. This is a topic that I'm not really an expert. I don't know about anything about energy, so I will use only the data that is provided in the data set. The process that I follow, the first step was to select the features, and one of the forms to select the feature is that was mentioned in the course is to interview people, especially experts in the domain. In this case, I don't know anyone, so I don't include that in the report. The only way or method that I can use is to use a statistical correlation. In this case, I'm going to use linear regression. I won't be using lasso regression. I'm going to trust that all the variables are somehow useful to predict the target variable. And I'm going to use another method in terms of the collinearity among the different variables in order to prove that linear regression is a good method to create the model. And it is also based on the diverse concepts that you need to take into account when defining or designing a model, which is interpretability, accuracy, and computational efficiency. Those three concepts are useful when using linear regression. This is not a complex model. It employs only a few features, 4 actually. And maybe since it is a very simple model, we could fall into an underfitting problem with that amount of features. We're gonna find out if that is true. And I'm gonna use validation, especially 5-fold cross-validation, in order to validate the model that I will be using. And I'm going to divide the data set, the entire data set, in training validation. I'm going to use 80% of the data, and I'm going to leave 20% for the test data set to test the model at the end after being validated. And the training and validation data set is going to be divided also in 80%. To be used as a training data set, and the 20% as validation data set. So before running or defining the model, I decided to run ANOVA and a regression using all the data, just to try to find some terms in terms of the multicollinearity, and to try to find the variance inflation factor among the four variables that are being used in this model. And I find out that most of the relations among the variables are close to 1. So this means that there is no collinearity among the variables, except one relation between atmospheric temperature and the exhaust vacuums, which is it is an intermediate collinearity, which is 3.4. So I decided to leave the two variables in the exercise, since it is an intermediate correlation. The number of observation is 9,568. As I mentioned, I'm gonna use the training validation 80%, which is 7,654, and the rest is gonna be for test data set. So I'm gonna leave also the last rows in the data as the test data set. Okay. So after running the 5 full cross validation, I run 5 iterations. The first one, I run these exercises to detect the mean absolute error and the mean square error, also the multiply R square, and the sum of square errors as well. So I detected that there is a high, I would say, a high mean square error of almost 20. But this is present because there are some outliers when you see some of the errors that can be close to 0, and some others are 4, some others might be -6, others 8. So this the size, others 9, for example, the size of these errors affect the mean square error. That's why it is a bit high. So that's why I am relying more on the mean absolute error, and also using the R square to detect how the model is close to the relation to the predicted variable and the real value. And this is the first iteration. I run several iterations, the five iterations. This is the second one. This is the third one, the fourth one, and the fifth one. Every time, of course, changing which part of the data set to be the validation, to use as the validation, and the other blocks to be used as the training. So you can see in this file the number of the rows that I employ for block 1, block 2, block 3, block 4, and block 5 in the iteration number 5, just to give an example. So as a summary, I try to show all the loss functions of most of the iterations, and I found out that, for example, that the iteration number 4, the mean square errors is the lowest one right here, and not in the mean absolute error right here, but it's very close to the lowest value, which is the iteration number 4, 3.56, 3.59. So most of the minimum values are right here in the iteration, and the highest values in terms of the multiple R and the R square are right here, that meaning that this iteration is the best, could be the best model to use. So I decided to use the model number 4 as the one to be used in the test data. So I applied the model number 4 using the coefficients from the iteration number 4 to predict the energy output right here. I calculated the error, calculating the real value minus the predicted value right here, calculated the absolute error, and then I square all the numbers. So you can find right here the test data set metrics, which is very close to the metrics of the iteration number 4. As you can see, 3.6, for example. If we go to number 4, 3.59, and the mean square error is 21, and right here is 19, and the multiple R is 0.96, and the R square is 0.92. This means that the variables are explaining the real value and the prediction value. So I didn't want to use the lasso regression because I don't know how to actually use any other program, another software, in order to make it more automated. I had to do all the and divide and do the splits manually, almost manually in using Excel. So I hope this can explain why I use the model. Okay, thank you very much.